Hey everyone, happy Wednesday. Hope that you're having a good one. Today we're going to talk just a little bit more about factored form, and then you're going to have a worksheet to fill out today. So this will be pretty short, just going to do a few examples, talk a little bit about what you get from factored form, and then you'll be off to the races. So let's get started without any further ado. So what happens when we expand something that's in factored form? Yesterday we learned a little bit about this. It tells us the x and y intercepts pretty easily. Our x-intercepts here are going to be whenever any one of these factors is 0. Because if one of these three things that I'm multiplying together is 0, then I'm going to have my entire function be 0. So it's going to cross through the x-axis. So for the x-intercepts, I can solve three equations. X minus 7 equals 0. That one's pretty easy. X equals 7. 2x plus 3 equals 0 is a little bit trickier. Subtract 3 from both sides, so I have 2x equals negative 3, and then divide by 2. I'd have x equals negative 3 halves. So that's my second x-intercept. So I'm solving for x-intercepts here. Then the last one, if x plus 9 is equal to 0, then x would have to be negative 9. Okay. So we have our three x-intercepts. So the whole goal here is kind of to try to figure out what the graph looks like. So put a graph up here, and we have an intercept that looks like at 7. 1, 2, 3, 4, 5, 6, 7 right there. We have an intercept at negative 3 halves. That's negative 1.5. So that's right there. And we have an intercept at negative 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, so those where all of our intercepts are. But we don't really know what the rest of the graph looks like. If we get our y-intercept, we can be told a little bit more. So let's see what our y-intercept is going to be. We learned yesterday that's just multiplying these three numbers together. So negative 7 times 3 is negative 21. Negative 21 times 9, let's see, 9 times 20 is 180, and another 9. So we have negative 189. So when you're sketching these graphs, the scale doesn't really matter. And this you might have noticed on your homework assignment yesterday, that actually there was one where like the ticks were each worth like 4. So in this case, we can just say negative 189 is right there. Let's say it's negative 189. Okay, so it crosses through there. So we know it comes down here and then back up. But we don't really know much about the rest of it. So let's see what happens when we expand this out. Let me get rid of some of my marks here so we can see these numbers again. So if we expand this out, we have to do it 2 at first, and then we'll do one more. So these first two, you can think about foiling them or making a box. I'm going to go ahead and foil because the next one I'm going to do is going to make a box. So we'll try to do it for kind of each different learning type here. So we'll foil this first one. X times 2x is 2x squared. X times 3 is 3x. Negative 7 times 2 is negative 14x. And then negative 7 times 3 is negative 21. So we have 2x squared. Plus 3x minus 14x is minus 11x, and then minus 21. And we're still multiplying this whole thing by x plus 9. So we don't have to like distribute to one and the other. We just multiply them one at a time. Because if you have like 3 times 4 times 5, you multiply by 3 by 4, which is 12, times 5 is 60. It's not like you multiply by 3 by the 4 and the 3 by the 5. You do it one at a time. So we're going to multiply now with these two. Now we'll make a box. So make it 2 by 3. Here we go. All right, so we have 2x squared minus 11x minus 21. We're multiplying by x plus 9. 2x squared times x is 2x cubed. Negative 11x times x is negative 11x squared. Then we have negative 21x. Over here we got, looks like 18x squared. Then we have negative 99x. And then our last number here is that negative 189. Combine our like terms. 2x cubed minus, let's see, plus, Monfransky, plus 7x squared minus 120x, and then minus 189. Now we learned yesterday when we talked about end behavior and stuff that these middle terms and time to the end, they're nice for stuff that happens in the center of the graph, but all that really matters for end behavior is this guy right here. We have an odd exponent and we have an positive leading coefficient. So that means our end behavior is going to look like this. Okay, it was one of the four. You can look back at the chart from yesterday if you need to see that. So we know we're going to start from the bottom. Looks like it's going to come through here. Going to come down. Going to go down to negative 189. And then it's going to go up. And there is our cubic polynomial. 2 turning points, 1, 2, 3 zeros. It's a cubic, so that all makes sense. And then that negative 189 at the end is our y-intercept. So my point in expanding this is you need to know how to expand this, because it's one of the things you're asked to do on your sheet today. But we can get these numbers the thing that tells us the end behavior and also the y-intercept, we can get those without actually expanding the whole thing. Check it out. If I multiply all of the x's together, so x, 2x, and x, that gives me 2x cubed. Gives me my front term. And if I multiply all of the numbers together, we already know that gives me the y-intercept. So what we can get from factored form is the x-intercepts, the y-intercepts, the end behavior. And that's really all we need to be able to talk about this. And also it'll tell us the multiplicities of the roots. So it'll tell us if it bounces or if it like flattens out and goes through. So these are kind of the big things we want to be able to get. And then also on the yellow sheet, it asks you to expand. So I'm just going to do some examples doing these 4 things. So the expansion is asking you to write it in standard form like this. So let's do some examples and see where it takes us. And of course, you always have Desmos, which is important. So I just kind of went through this. I actually did it on the other slide, which is just fine. So the x-intercept, y-intercept, and the end behavior are the things that factored form tells us. So x-intercepts, y-intercepts, you don't have to write this again, and the end behavior. I was more prepared than I thought I was. Okay, so that's what factored form tells us. And we're also going to be able to expand it and put it into standard form. So let's try some examples. This first one, we have, looks like 1, 2, 3 x's, so it looks like we're going to end up having a cubic polynomial. Let's write out the things we know. The x-intercepts are when any one of these things is 0. So you can write out the equations every time. X minus 3 equals 0, 2 minus x equals 0, and 1 plus 2x equals 0. But after you do this a little while, you start to just kind of see these. I look at x minus 3 and say, okay, well, if x is 3, the 3's are going to cancel, I have 0. So 3 is my first x-intercept. 2 minus x, well, if x is 2, those are going to cancel. And then 1 plus 2x, this one's a little trickier, but I want that 2 to cancel with something on the bottom. So I need x to be maybe like 1/2, that would cancel the 2. But I need to do 1 plus this to cancel out, so I would need a negative 1/2. Because if it's negative 1/2, the 2's will cancel, so I'll have 1 minus 1, which is 0. You can also just solve this. 1 equals negative 2x, divided by negative 2, negative 1/2 equals x. Okay? Any way you do it, as long as you get the x-intercepts, it's going to be okay. So let's start kind of a picture of the graph over here. So 1, 2, 3 is going to be an intercept. 2 is an intercept. And then negative 1/2, which is right there, is going to be an intercept. The multiplicity of these, well, if we look at our powers, we have no powers up here on the roots, so they're all 1. So the multiplicities are all 1. It's just going to go straight through each one of those. Now let's think about the end behavior. So the end behavior is going to depend on the leading coefficient. That's all that matters, the leading coefficient and the degree of the polynomial. We have 1, 2, 3 x's, so it's just going to be an x cubed. And then if we look at the signs, it's x, just a 1x, and then we have a negative 1x. Okay, that's important. And then we have a positive 2x. Multiply those all together, we have a negative 2x cubed. So because it's negative, and we have an odd, it's going to start from up at the top, like that, and it's going to end down at the bottom. Okay, that was one of the ones from our grid yesterday. Now we just have to see where our y-intercept is, and we'll be done. So the y-intercept is going to be just the numbers multiplied all together. So we have to look at the constant term in each factor. So it looks like that's a negative 3, a positive 2, and a positive 1. Multiply those all together, we get negative 6. So negative 1, 2, 3, 4, 5, 6 right there is our y-intercept. So we come through, probably going to have to be a little closer to the axis to get down to that negative 6. So something like this. And then it's going to come up this way, and then it's going to go down. Cool. Well, I'm always excited to see how we did if we go to Desmos. So let's go over to Desmos, and let's type in our function, and we'll see how we did. Come on. No, back. Go away. Keep. And here we are. So let's see what we had. We had x minus 3 times, I think it was 2 minus x. So you can, I like kind of watching the parabola here and how it comes up. And then we had, I think it was 1 plus 2x. So let's see how we did. Well, there's our negative 1/2. There's our positive 2, and there's our positive 3. There's our y-intercept at negative 6, and we see that our end behavior was right. So we can sketch this graph without having to touch a calculator, which I think is pretty cool. All right. You're like, yeah, Fransky, let's just get on with the examples. So let's take a look here. Okay, moving on. actually, first I want to be able to put this into expanded form. So I'm going to erase these guys again so we can actually see what's going on. Oh, it kept my marks, so I can't erase them. That's just fine. So if we multiply here, we can FOIL the first ones. We got 2x, change my color to minus x squared minus 6 plus 3x. Put that all together. Let's see, we have negative x squared. And then we have plus 3x plus 2x is plus 5x, and then minus 6. That is multiplied by 1 plus 2x. So we can make a box again. I'm actually going to multiply one at a time here just to kind of show that there are multiple ways to do this. So multiply the first terms. That gives us a negative x squared. And then our first and our last terms gives me a negative 2x cubed. Then the next terms, 5x times 1 is a positive 5x. And then plus 10x squared. Then we have negative 6 times 1 is minus 6, and negative 6 times 2x is minus 12x. Gather our like terms here. Looks like our negative 2x squared is out front, which is how we found our end behavior. And then we have negative x squared and plus 10x squared is plus 9x squared. Could help to cross these out one at a time. Let's see here. And then we have plus 5x minus 12x is minus 7x. And then we have minus 6. So that is our expanded form. And that's what I expect you to be able to do on the worksheet you're doing today. Let's try another example. Let's change our color. Red is offensive. Back to this guy maybe. All right. So here we have a fifth degree polynomial, and the reason I left this in here is because I want to talk about how we know this. So if we expanded this out, right, that square does not just get distributed. Be careful with that. That's a no-no. So it's x minus 1 times x minus 1, and then we have x plus 2 times x times x. Okay, so we have 1, 2, 3, 4. There are 5 x's there. We could have just added our powers too. 1, 2, 3, 4, 5. All right, so altogether we have a fifth degree polynomial, and we have different multiplicities. So that's going to change the shape of our graph. It's also going to kind of affect how we're going to expand this out when we're done. So let's do our x-intercepts. X-intercepts here are when any one of these factors is 0. This guy is 0 at 1. This guy is going to be 0 at negative 2. And this guy is going to be 0 at 0. Now it's easy to forget that one, but you could write that as x minus 0 squared. And then it's easy to see that the 0 is going to be when x is 0, but just as x squared, you got to remember that that's going to be one of your zeros as well. So we have our x-intercepts. Let's do it a little different order this time. Let's do the y-intercepts. Now this one's a little harder because we have to remember to square that negative 1. So you can write it out expanded like this if you want to. That'll be able to make it clear that you have negative 1 times negative 1, which is positive 1. Then times positive 2 is going to give me positive 2. But because we're plugging 0 in for x, we actually have it all multiplied by 0, so our y-intercept's just 0. It's going to go through right at 0. Right? If the x-intercept, one of them is 0, that crosses at 0, 0. So we're going to have, for sure, the y-intercept of 0. Let's talk about end behavior. So the end behavior this time, we have to look at our x's. We have a 1x here. We have a 1x here. We have a 1x here, a 1x here, and a 1x here. So it's just going to behave like 1x to the 5th. So that has a positive leading coefficient, and our exponent is odd. So it's going to have end behavior like this. I might have to move those depending on where the intercepts are, but we'll see. So our x-intercepts are at 1, negative 2, and 0. It's going to be important to look at our multiplicities here. So I should have listed the multiplicities right underneath, but 1 has a multiplicity of 2. Negative 2 has a multiplicity of 1, and 0 has a multiplicity of 2. So at both of these spots, it's going to bounce. It's going to bounce at both of those spots. So at negative 2, we go through, like that. Then we're going to bounce, and bounce again, and then we're going to go up like that. And that's it. Let's graph this on Desmos and see how we did. Oh, come on. All right. So this time we have x minus 1. Oh, I should probably do a new graph. We got x minus 1 quantity squared. And then we have that multiplied by, oh, come on, get down. Multiplied by x plus 2, and then times x squared. Get rid of our other graph. and we do see that we have something that comes up, and then it bounces twice, and then goes off to infinity. And that's it. I got one more example here for you. And let's take a look at it. Well, first I want to expand that last one. I keep forgetting to do that. So if we're going to expand this, the square, remember that means we're multiplying it by itself. Now you might know the shortcut for when we're squaring something here. That shortcut is just the first thing squared, which in this case is x squared. Oh, change my color again. That's fine. So x squared minus 2 times the first times the second, which will be minus 2x, and then plus 1. So we have that multiplied by x plus 2 times x squared. So let's multiply by the x plus 2. So I'm going to do one at a time again. X times x squared is x cubed. X squared times 2 is a 2x squared. Then we have minus 2x squared. That's that guy. And then we have minus 4x. And then we have plus x plus 2. Right? Plus x plus 2. This is all multiplied by x squared. So I just have to do x squared times all of those different things. So that gives me x to the 5th. X to the 5th, we said it was a 5th degree. And then plus, let's see here. So the 2x squareds actually cancel. So we have negative 4x plus x is negative 3x. So negative 3, and then x times x squared is x cubed. And then we have plus 2x squared. And that is our polynomial. Not bad. All right, last example. So this time we've got some multiplicity stuff going on again. Let's see if we can figure it out. Let's do our x-intercepts first. X-intercepts, 2x plus 1 is equal to 0. 2x plus 1 equals 0. That only works out if 2x is negative 1, which means x is negative 1/2. And then our other one is going to be x equals 6. Let's think about our multiplicities. Negative 1/2 looks like it has a multiplicity of 3, so it's going to go flat and then pass through. And then this guy over here has a multiplicity of 1. It's just going to go right through. End behavior. Well, let's look at our x's. We have a negative x here times a 2x here, so it's going to be a negative 2x squared. So negative 2x squared has a negative leading coefficient, and we have an even power. So that means it's going to look something like this. Okay, something weird's going to happen in the middle. Our y-intercept is determined by all the constants. So that's 1 times 6, which is 6. 1, 2, 3, 4, 5, 6, right there. If I could draw. 6, right there. Okay. So, let's see what's going on with our intercepts here. X at negative 1/2, that's right there. And then at positive 1, 2, 3, 4, 5, 6, right there. Get rid of my arrows here because they're going to have to move a little bit. So we come right through the axis here. I'm going to go up and have that intercept. And, oop. That's a lie. I did that just barely wrong. So it has to be flat there. So actually it's going to come up like this, flatten out because of the multiplicity, and then come up. Sheesh, it's a tough graph to draw. And then it's going to go straight through at 6. So it looks something like that. Let's expand it, and then we'll take a look at it in Desmos. So if we expand this thing, it looks like we're going to have 2x times, well, we got to cube this thing, actually. So cubed means we multiply it by itself 3 times. So we have 2x plus 1 times 2x plus 1 times 2x plus 1 times 6 minus x. Oop, x, not 6. So I'm going to multiply these 2 at a time. I'm going to pretend we're multiplying these together and these together, which is fine. You can do it any order you want. So these two multiplied together is 2x plus 1 squared. I'm going to use a shortcut on that. So that's the first thing squared, which is 4x squared, plus 2 times the first times the second, which is going to be plus 4x, and then plus the last thing squared, which is just plus 1. And that's multiplied by, let's see here, 12x minus 2x squared plus 6 minus x. Altogether, that looks like negative 2x squared and plus 12x minus x is plus 11x, and then plus 6. Now to multiply these together, we can make a box, or you can do it one at a time. Let's make a box over here. It's going to be 3 by 3. 4x squared plus 4x plus 1. And then we have negative 2x squared plus 11x plus 6. So that looks like negative 8x to the 4th, minus 8x cubed minus 2x squared. Here we're going to have 44x cubed, 44x squared, and 11x. Then down here we have 24x squared, 24x, and 6. So altogether that's negative 8x to the fourth, plus 36x cubed. And then we have 24 and 44 are 68, minus 2 is 66x squared, plus 35x, plus 6. There's our expanded form. So not too bad. X-intercepts, y-intercepts, ending behavior from the left and the right. And I think they ask you to do that with limit notation. So we have to write this limit as x approaches negative infinity of f of x is equal to negative infinity. Over here, limit as x approaches positive infinity of f of x would be negative infinity as well. Because as x gets really big, the function values are getting smaller and smaller. All right, your homework. The yellow sheet, you should have gotten that from Mr. Fleming. Solutions are on Moodle along with the Chapter 2 textbook. I'm sorry I didn't have that available before Collab yesterday. That was my bad. And email me, please, with questions, noah.fransky@dynaschools.org. Had some great questions yesterday emailed to me and was able to reply to them quickly and get them solved. And remember, I'm back tomorrow. We'll be doing review and questions tomorrow. I'll also be around for collab time, so feel free to come in for that. Quiz is on Friday. And because it is Wednesday, I've got a crypto quip for you. So take a look at the crypto quip if you like, and I'd be happy to talk over solutions tomorrow for anyone that gives it a shot. Love you guys. That's why I'm here. Have a great day. Bye-bye.